Okay, let's take a look at this Unit 7 practice test. We've been learning how to solve systems of equations using matrices, among other things. So let's take a look at number 1. It says solve each system using substitution or elimination. Show your work. So that means we need to make sure that we're showing our work by hand. We're not going to be using the calculator for these, other than just kind of miscellaneous arithmetic and stuff like that. So remember, it says circle your answer and round to the nearest hundredth when appropriate. So we'll just round to 2 decimal places here. So let's see what we get. This one's clearly set up for substitution. Y is equal to x squared. So we're just going to put that right in the place of y. So wherever there's a y, we're going to put an x squared. So this is going to be 3x equals x squared plus 2. And then we're going to move this around. So we've got this quadratic set equal to 0. So I'm going to subtract 3x. And I'm going to have 0 equals x squared minus 3x plus 2. And then we'll factor this. That's probably the easiest way to solve this. So I need two numbers that multiply to be 2 and combine to be negative 3. So that's going to be negative 2 and negative 1. And when we set each one of these factors equal to 0, the solution that comes from this one is x equals 2. And the solution that comes from this one is x equals 1. So those are the x values. Now we need to plug those back in and find the y values. So if I take x equals 2 and plug it back in here, I get y equals 2 squared, so I get a 4. So those two would go together, so this would be 2 comma 4. So there's one of them. And then the other one would be y equals, this would be 1 squared, so that's going to be a 1. So the other one I get is 1 comma 1. So there, whoops, there are the two answers on this one. Okay, let's come over and take a look at this one. Again, this one's set up for substitution, and what I can do is I'm going to do this. Wherever there's a y, I'm going to put x squared minus 2x plus 3. So I'm going to put that right here, and I get x squared minus 2x plus 3 equals, on the other side would be 3 minus x. So I'm going to subtract 3, take care of that. I'm going to add 1x, take care of that. So this is going to give me x squared minus x. We've got no constant value right there. And then we're going to take out an x. I'm left with an x minus 1. Make that look like a minus 1. And then so I get an answer of x equals 0 from that one, an answer of x equals 1 from this one. So if I plug in a 0 into this, I get y equals 3 minus 0. So I end up with a 3. So one of the answers is 0 comma 3. There's one of the xy pairs. And then the other one would be y equals 3 minus 1. So we end up with a 2. So the answer that comes from that is 1 comma 2. So there are the two solutions on that. Didn't require any rounding or anything. So we'll take a look at this one. Now, it's not always the case that this is set up for substitution with y. Sometimes the x will be by itself, and we probably could have moved this one around so x was by itself there. But on this one, it looks like it's going to be y again. So wherever there's a y, we're going to put x squared plus 1. So this is going to be 2x squared plus 3. And then in place of the y, we're putting x squared plus 1. And that will equal 5. So I'm going to get 2x squared plus 3x squared plus 3 equals 5. So we'll get 5x squared plus 3 equals 5. I'll move the 3 to the other side. So we get 5x squared equals, let's see, this is going to be a 3, no, 2. And then we're going to divide by 5. So we're going to have x squared equals 2/5. So we'll take the square root of both sides. So we're going to end up with x equals plus or minus radical 2 over radical 5. And I'm going to rationalize the denominator, radical 5 over radical 5. So this is radical 10 over 5, and that's plus or minus. So x is going to equal plus or minus radical 10 over 5. And then I'm going to take that and I'm going to plug it in over here. So let's see what we get. If I plug it in here, we're going to get y equals radical 10 over 5, quantity squared plus 1. So I'm plugging into this first one here. So this is going to be, let's see, that would just be a 10, and that would be a 25 plus 1 So this is going to be 2/5 plus 1, so that's going to be 7/5. And if you'll notice, it wouldn't matter if we plugged in a positive or a negative, because if I put a plus or minus here, it's going to end up being the same value. So what we get here is x is going to be radical 10/5, comma, 7/5, and the other one would be negative radical 10/5, comma, 7/5. Now, if you wanted to do that on a calculator and throw it in, I suppose you could do that, but there's an exact answer right there with no rounding or calculator required. And then let's take a look at this one. Again, this one's set up for substitution. I'm going to put this right in here. So this is going to be x squared equals x minus 1. We're going to move all these over. So this is going to be x squared minus x plus 1. Set that equal to 0. So here's what A is. There's B and there's C, because we're not going to find any numbers that multiply to be 1 that combine to be -1. So we're going to be using the quadratic formula on this one. So this is going to be x equals, this is going to be -1, so opposite -1, so that's going to be 1, plus or minus b squared, so that's going to be 1, and minus 4 times a times c. That's a 1 and that's a 1. And on the bottom is going to be 2 times a is a 1. So let's see what we've got here. This is 1 plus or minus big square root. This is going to be 1 minus 4. So this is going to be a -3 there, and then that's all over a 2. So the fact that we've got a negative underneath here, this is going to be imaginary answer. So there's going to be no real solution. There's not going to be a point on the xy plane where these cross. And if you wanted to say no solution or no real solution, that'd be totally okay. Either way's fine. Okay, let's take a look at this next group of problems. It says sketch and solve the system using a calculator. Let's run through and see what happens here if we just graph this really quickly. So I'm going to subtract the x from both sides. So this is going to be y equals -x plus 4. And this one's already solved for us. So this one crosses at 4. And it has a slope of -1, so it's going to look something like this. Crosses at 4, perfect 45 going down, so we're going to have that. And then the other one, I'll do this in a different color. This one is crossing at -4, and this is a parabola. Regular old shape, hasn't been stretched or shrunk. So over 1 up 1 squared, over 2 up 2 squared, over 3 up 3 squared, so that's going to be up 9. That's going to put us right here. And then the equivalent points on the other sides. So whoops, it's going to look something like this. And clearly, when we take a look at where that crosses, it's not going to cross at a nice point. So we're going to use the calculator to figure out what our answer is here. So I'm going to shrink this down just a little bit. Let's see. And pull that up here. Shrink down here. And we're going to put in, let's see, -x plus 4. And the other one's going to be x squared minus 4. We're going to hit graph. Looks pretty good. And then we're going to have the calculator. Again, this is going to be second trace, second calc. And we're going to do number 5. We do have to say, yes, the line is the first curve. And the parabola is the second curve. And then I'm going to go for the one on the left first. So somewhere around right, whoops, went a little too far, around right there. And it says the intersection is -3.37 and 7.37. Okay, that looks okay. So one of them is going to be -3.37, comma, 7.37. And then the other one, again, we'll do second trace. We'll hit number 5, and yes, and yes. And then I'm just going to enter a 2 and see where that hops. 2 would be about right there on that graph, and it's going to find that one for us. So again, notice that this rounds the same way. So this is 2.37. So we're on the right side of the x-axis now. So 2.37, or the y-axis, 2.37. Got to get a 2 here. 2.37, comma, 1.62. 1.62. That 7's going to bump it up, so that's going to be 1.63. Okay. All right, let's take a look there, double check and make sure we've done everything right. Yep, that looks pretty good. Okay, and now these guys, this is matrix multiplication here, so let's take a look at what we've got. We've got a 2 by 2 multiplied by a 2 by 2, so we're going to end up with a 2 by 2. And we just want to check and see if these are inverses of each other. So remember, we're going to multiply the two of these and see if we end up with a identity matrix. So this is a 2 by 2 here. First row, first column. So I'll take the first row, multiply it with the first column. So I've got 2 times 2 is 2. Negative 1 times 1 is negative 1. So we do end up with a 1 right here. And then the next one is first row, second column. So I'm going to take the first row, multiply it with the second column. So I've got a 2 times 1 is a 2. Negative 1 times 2 is a negative 2. So we end up with 0 there. And then it's going to be the second row, first column here. So we're going to take the second row and we're going to multiply it with the first column. So this is a 1 and this is a negative 1. So we end up with a 0 on that. And then this is second row, second column. So I'll take the second row and multiply it by the second column. So we multiply the two of these together. We get a 1. Multiply the two of these together. And we end up with a negative 2. So this is going to be a negative, this is going to be a negative 1. So the answer on this one is no, they're not. Okay? So this would have to be a positive 1 in order for that to work out. So the answer on that one is no. Okay, number 7, it says find the inverse by hand. So the first thing we need to do is, this is a square matrix, so there's a possibility that it has an inverse. We need to figure out the determinant. So on the determinant, we multiply the downward diagonal, and we end up with a 12. Then we subtract the upward diagonal, so that's going to be a 2. So we end up with a 10. So yeah, we're going to be able to find the inverse of this. It's going to be 1 over the determinant, and then we move these around in kind of a specific way. We're going to switch places with the two of these, and we're going to change the sign to the opposite sign for the upward diagonal. So the downward diagonal changes places, so this is going to be negative 3 and negative 4, and these two become the opposite sign that they used to be. So the 2 is now going to be a negative 2, and the 1 is now going to be a negative 1. And then we just take this and we multiply through. This is just scalar multiplication at this point. So this is negative 3/10. When we multiply here, this would be 1/10 times negative 2. That's going to be negative 2/10, which we can reduce to 1/5. So that's going to be 1/5, and it would be negative. And then we get a negative 1/10 when we do the scalar multiplication here. This would be 4/10, negative 4/10, but that's going to reduce to negative 2/5. Okay, so there's the inverse right there. Again, pretty quick. Don't even need a calculator on this. So if you want to check your calculator, you're welcome to. On both of these, but not necessarily required. Let's come down here, and it says write the ordered triple that represents the answers to each system in the augmented matrix. And you might need to choose an independent variable or variables in order to write the answer. So on this one right here, you'll notice that we've got this in as much as we can in reduced row echelon form, but the last row represents zeros. So what this means is z is any real number. So then this equation, the second row represents, because remember this is an x, this is a y, this is the z, and this is the answer column. That second row represents the fact that 1y minus 3 z's equals a 1. And that first row represents the fact that an x plus 5 y's minus 4 z's equals negative 2. So for this one, I'm just going to move this around and say, I'm going to add the 3z to both sides, and I get y equals 1 plus 3z. Now, we could go through and do some row operations and get rid of this right here and really try and have this in as much of reduced row operation, reduced row echelon form that we can. But here's what I've got so far. I've got z can be any real number. Y, once we figure out what z is, y would be 1 plus 3z. And then I'll solve for x, and x in this case would be, if I move these over, this is going to be a negative 2 minus 5y. I'm going to make this a little bit bigger so I can write here. Minus 5y plus 4z. So in order to get this right, the only thing I need to do here is I just need to replace this y with what it is in terms of z. So this is going to be x equals negative 2 minus 5, and this is going to be a 1 plus 3z, and then plus 4z. So this will be negative 2, and this is going to be minus 5 minus 15z plus 4z. So this means x is, let's see what we get here, negative 7, and then minus 15z. Oh, that's minus 11z. Minus 11z. So that means our solution to this would be negative 7 minus 11z, comma, 1 plus 3z, because there's the x, there's the y, and then z can be any real number. So this is what our solution is going to be. We've got each one of the pieces here, and then we just put them together, and this is the final answer right there. Okay, let's take a look at the next one. One right next door here. Let me make that the right size. And let's see what we've got. Again, this is pretty much in reduced row echelon form as much as we can, but not quite. Because if you take a look here, we've got the 1 and the 0 and the 0 and the 1 and the 0. Not right here. We didn't make that one a 0, and we've still got this one. So you could do a couple of things here. You could put this in your calculator. You could do some row operations to get this in reduced row echelon form, or we can just take the pieces that we know and then solve for that. So again, this is the x column, the y column is the z column, and the answer column. This one right here means that z is equal to negative 3. And this one right here, that means that y is equal to 0. And this one right here, this is what that means. This means that x minus a y plus a z is equal to 1. And if we know what these values are, we're in pretty good shape, because if I take this and move it around, this means x is equal to y minus z plus 1. So if I move everything on the other side and then solve for that, I get a 0 minus a minus 3 plus a 1. We end up with, that's a 3 plus 1, so we end up with a 4. So the values that we need are right here. We've got x, y, and z for each one of these. So this is going to be, let's see, we've got a 4, comma, 0, comma, negative 3. Let's close this off, and that's our answer on that one. Okay, let's take a look at the other side. Okay, we're on the back side now. It says solve each equation or system using row operations in a calculator. Write the augmented matrix at the beginning and the end, and write the shorthand for each operation. So I suppose you could do some of these if you wanted to by hand. I think there's enough space here. But really, once you get used to the calculator, again, it's just probably going to be quicker and more accurate, because if you make a single mistake by hand, you're going to get the wrong answer, and it's going to be a little frustrating. So the first thing we're going to do on number 10 is we're going to write down the augmented matrix that we used to start. So this is going to be 16, 12, 6, negative 4, negative 3, and negative 2. And I often forget to put the line right there, so that'll happen occasionally. All right, so we're going to take a look at this. I'm going to hit second quit. I'm going to go to the matrix menu. I'm going to edit this, and I'm going to put 2 rows and 3 columns. So a 2 by 3, and we'll come down here. We'll do a 16. We'll do a 12. We'll do a 6, and I'm very slow at this on the calculator because I've got to use a stylus and just hit every button one at a time. Let's see, so I think I've got that in right there. I'm in edit mode, so that's the best place to double check. So I'll hit second quit. Always go back to the home screen. I'm going to display the name of the matrix, make sure that I'm in good shape. And that looks like I've got it in there right. And then I'm going to do this. We're going to turn that first one, our first goal is to turn that into a 1, so we're going to multiply by 1/16 times row 1. And I'm going to make this a little bit smaller so I can see those both at the same time. Keep the calculator up. So just 1/16. We don't need to turn it into a negative. So this is just 1/16 times R1. So we'll grab the row commands. So I'm going to hit second in matrix, math, and we're going to times that row. So it's that one right there. So we're going to do negative 1/16. And you can put this in as a fraction if you want to, if you only use the fraction menu. Sometimes that's helpful. Whoops, and not the negative. I don't know why I keep doing that. We're going to hit delete. And let's see, matrix A, comma, row 1, and hit enter. And it did turn that into a 1, so I'm going to store that. So I hit the store button and the name of the matrix. And again, once I get these down, I've got these in the deep recall history of the calculator, so I'll be able to make the commands a little more quickly. Okay, next thing we want to do is use the 1 to make that a 0. So what do I add to -4 to make it a 0? I add 4, so that's the number we're going to multiply the 1 by. So 4 times row 1, and we're going to add that to row 2. So we're going to hit second matrix, come over here, hit the up arrow. F is the times row add command. We're going to multiply by 4, comma, the name of the matrix is A, we're going to grab that, and we want to multiply row 1 and we want to add it to row 2. Double check, make sure I've got that in there the right way. Looks pretty good, so I'm going to go ahead and store that, and again I can just hit second enter a couple times, store that, and you'll notice that I've got a 0, 0, and a -0.5. So we're done at this point. We just need to know how to interpret that. So 1, and then I'm going to write that as 3/4. And this is actually, gosh, if I needed to, I can hit math, change that to a fraction. So 3/4, 3/8, 0, 0, and -1/2. And because this row basically says 0 equals -1/2, we're going to say there is no solution to this because that is not a true equation. Okay, let's take a look at the next one. We'll put that in. Let's see, we've got 1, 2, 13, 5, 2, 25. And we've got goal number 1 already taken care of for us, so that's kind of cool. And I'm going to make sure that this is in the right way, so we're going to hit second quit. We're going to, whoops, probably didn't need to do that. We're going to go back and edit. And it's already a 2 by 3, so we're going to do 1 and 2 and 13 and 5 and 2 and 25. Make sure we got that in there the right way. Looks good. Now we'll do second quit. Name of the matrix. Got to get this right. Second and matrix. There we go. Name of the matrix. Make sure that I've got those in there right way. Okay, I think I do. That's already a 1, so we're going to use the 1 to turn that 5 into a 0. So what do we add to 5 to make it a 0? -5. So -5 is the number that I multiply by. I'm using the number 1 in row 1, and I'm going to add it to row 2. And remember, we've got a times row add command back there just a little ways, not too far. You could make it from scratch if you wanted to. So row 2 is the one that's going to get changed. Row 1 is the one that I'm going to multiply. And I just need to change that into a -5. So I'm going to hit second and insert, -5, and I'm going to delete the 4, make sure that it looks right. Hit enter. It did what I wanted, so that's nice. I'm going to save that. So I'll just hit second enter a couple of times. Again, could have done that by hand. All right, let's see. Okay, we've got the 1 and the 0. Now I want to turn that into a 1, so I'm going to multiply by the reciprocal of that. So that's going to be -1/8. So -1/8 times row 2. And the times row command is far enough back there, I think I'm just going to go ahead and make that. So we're going to do the times row command. And this time I will do it as a fraction. So we're going to do alpha y equals, and I'm going to do a -1 on the top and an 8 on the bottom. And the advantage this has is, depending on how old your calculator is, your calculator might throw some really weird numbers at you in engineering notation, like a 0 will be some teeny tiny decimal. Putting it in as a fraction may be helpful for that. And we're just going to multiply row 2 by that -1/8. I think I've got that in there the right way. And that looks good. So I'm going to hit second enter a couple of times, recall the store command, and then the last thing I need to do is I need to turn that into a 0. So I need to add a -2. So this is going to be -2 times row 2, and we're going to add to row 1. So the times row command is back there a little ways, probably worth me going back there and finding it. And I need to change this to row 1. I need to change that to row 2 because we're multiplying row 2 and adding it to row 1. And I just need to change that so that it matches the 2 right here because we're multiplying by -2. Hit enter and notice that it did what we want. So we're going to write down the end of this. This is 1, 0, 3 and 0, 1, 5. Okay, there's the augmented matrix that finishes it. So that means the answer to this one is 3, 5. That would be the point where these two lines cross. Okay, let's take a look at the next one, and I'll go full screen on this one. Well, actually, I think what I'll probably do is just write down the two augmented matrices here before I make this smaller. So here is the first one. So notice that there's no real shortcut to any of these. So I'm just going to go ahead and write them down. 3, -2, 4, 23, 2, 1, -5, -14, and -4, 1, 1, -8. Okay, let me just double check and make sure I got that right. Looks good. Okay, I think we're okay there. And then on this one, let's write down what we've got here. I've got a 2, 3, -1, and a 4, a 2, a -3, a +1, and a -12. And then we've got a 4, a -1, a -1, and a -8. And I'll make sure that I've got that right. Okay, looks like we've got it pretty good there. Okay, so now we'll go ahead and turn our attention to what's going to go on this one. And we'll put that in the calculator. So let's see, I'll hit second quit. Come back to the math menu, the matrix math menu. I'm going to change this. We now have a 3x4, so 3x4. Whoops. Go back here. That's the trouble. 3x4. And there we go. 3, -2, 4, 23, 2, 1, -5, -14. And that last row is -4, 1, 1, -8. And we'll double check while we're still in edit mode. Okay, I think we're in good shape. So I'll hit second quit. Display the name of the matrix. And double check one last time. Looks like we're in good shape. Okay, let's go for these goals. There's actually 9 of them. We got to turn that into a 1 and then use that 1 to make those zeros. Turn that into a 1. That may change in a few minutes. So we've got 9 goals here. So first thing I want to do is I want to turn the 3 into a 1. Now there's a couple different ways that I could do that. If I want to avoid fractions, what I could do is I could take this 2 and I could multiply it by -1 and I could add it to that one right there. So there are many ways to do these. I'm going to do this so that I avoid fractions. And here's what I'm going to do. I'm going to do -1 times row 2, and I'm going to add it to row 1. So I'm going to recall that command, or I'm just going to make it from scratch. Let's see, it's not too far back there, I don't think. There it is. So that's actually almost what I need. We're going to multiply by a -1. We're going to multiply row 2 by -1, and we're going to add it to row 1. So if I do that, notice that that turns into a 1, and I have the advantage of not making any fractions, because the other option would be to multiply by 1/3, and that just tends to turn into a mess. So this is what I'm going to do, and I'm going to store that. So I'm going to hit store, name of the matrix, hit enter, and there we go. Now, I need to use that 1 to turn those into zeros, so I'm going to need to add -2 to that. So we're going to do -2 times row 1 and add to row 2. So we're just going back and forth with the two of these guys. And then I need to add a +4, so I need 4 times row 1, and I need to add to row 3. So let's go ahead and do those. And I'm going to go back and I'm going to grab that times row add command. And let's do this one first. So we're going to multiply by -2, and we're going to multiply row 1 by -2, and we're going to add it to row 2. And we're going to hit enter, and it did what we want, so that's nice. So I'm going to hit second enter, store that. So now I'm on this one, and I'll recall the times row add command. So let's see what we end up with here. This is going to be a 4, and I get to delete this one. And I'm multiplying row 1 and I'm adding it to row 3 because I want to turn that into a 0. So I hit enter. Looks like it did what we want. So I'm going to hit second enter, second enter, recall the store command, and now I need to turn that one into a 1. So we are going to end up with fractions on this one. So we're going to multiply by 1/7. So it'll be 1/7 reciprocal of 7 times row 2. So let's see what we get here. I'm going to build that from scratch. So we're going to do the times, and I did store that, right? Yep, I did. So we're going to do the times row. So that's this one right here. And I'll go ahead and put it in as a fraction. So I'm going to hit alpha y equals. And we get, whoops, I need to get that out of the way. There we go. 1/7, comma, matrix A, comma, row 2. And let's see if that does what we want. It does, and it makes some fractions there. Notice if you put it in as a fraction, it will keep the fractions there instead of turning them into decimals. So I'm going to hit store that. And then we're going to use the 1 to turn those into zeros. So that's going to be, I need to do 3 times row 2 and add to row 1. And I need to do 11 times row 2 and add to row 3. So let's go ahead and do that. And I've got a times row add command not too far back there, so I'll just go back and grab it. And let's do this one here. I need to do a 3 and row 2 and add to row 1 and hit enter. Does what we want there. So I'm going to hit recall that store command. Now I'm going to do the other one. Okay, so we're going to times by 11. So I need to move space here. So this is a 1 and insert a 1. And then we're going to multiply row 2 and we're going to add it to row 3. Hit enter. Okay, so we've got that. We're in good shape there. Let's see, I'm going to store that because I like the work that it did. Okay, and now I need to turn that into a 1. So to turn that into a 1, I need to multiply by the reciprocal. So the reciprocal on this one is going to be 7/6 times row 3. So let's see, we're going to times a row. So I'll just make that one from scratch. Oops. Times a row, and we're going to do 7/6, so I'll do a fraction. 7 on top, 6 on the bottom, and comma, name of the matrix, comma, which row? We're doing row 3. Hit enter, does what we want, and nice, it turned out to be a nice integer there. So we'll store that, like the work that it did. And then we're going to get rid of these guys right here. So I need to add 6/7 to that one. So this is going to be 6/7 times row 3, and we're going to add to row 1. And we need to add 23/7 to this one. So 23/7 times row 3 and add to row 2. So we'll do both of those operations there and see what we've got. Let's see. So I'm going to do the times row, and we're going to add it to another one. So we're back here a little ways. So we're going to come in here, and with the fractions, sometimes they fit, sometimes they don't. So we're going to do this 6/7. So I'm going to hit delete, delete, and then I'll insert. And we're going to do alpha y equals. And we're going to do that fraction, and that fraction is 6/7. And we're multiplying row 3, and we're adding it to row 1. And some people are good at just editing going backwards. I tend to like to do it forwards, but we'll see how this works out. So hit enter. We like what it did, so I'm going to store it. And then I'll just have one more to do. We've got this last one, 23/7 times row 3. Really similar to the one that we just did. So I'll go ahead and edit this one going backwards. So that's going to be a 2, and we'll just make sure that we get everything right here. That is 7ths, and then, oops, and then we've got 23. Okay, so I'll come down here, 23/7. Looks good. Matrix A, 3, 2. We're good, and there we go. Okay, so we've got that in reduced row echelon form. I'm going to quickly save that. And so the answer on this one, if we write it down in augmented form, is this 1, 1, 1, 0, 0, 0, 0, 0, 0. And then we've got the 1, the -6, and the 2. So the solution, the point where these planes cross, is 1 comma negative 6 comma 2, and put a box around that and we got our answer. Okay, let's take a look at the next one. So I'm going to clear this off and we'll go back to the matrix menu and we'll edit this. And this is a 3 by 4, so we're in good shape there. And I need a 2, a 3, a negative 1, a 4, a 2, a negative 3, a 1, and a negative 12. And then I need a 4, a negative 1, a negative 1, and a negative 8. Let's double check and make sure we've got that in there. Okay, think I've got it. I'll hit second quit, display the matrix, double check one more time, make sure that I've got everything in there the right way, because it can be really frustrating if you've got the wrong thing in and you're doing the right steps with it. Okay, so the first thing we're going to do is we're going to turn that 2 in row 1, column 1 into a 1. So we're going to do 1/2 times row 1. So we'll make that command from scratch. We're going to times by, and I'll do the fractions. So this is going to be a 1 on the top, 2 on the bottom, comma, name of the matrix, comma, and then row 1. We like what it did. It turned that into a 1. So I'm going to recall our store command. I don't think that's too far back there. And then we're going to use the 1 to make that a 0. So that means, what do we add to 2? A negative 2. So this is going to be negative 2 times row 1, add to row 2. And at the same time, I'll write this one down. We would add negative 4. So this is negative 4 times row 1, add to row 3. So we're going to make a times row add command. And we're going to multiply by negative 2, comma, matrix A, comma, row 1, comma, row 2. Hit enter. We like what it did, so we're going to store it. And recall that times row add command so I can do it again. We're going to be changing row 3 on this one. We're still using row 1, but this time we're multiplying by negative 4 because we want to turn that into a 0. And hit enter. Did what we want, so we're in good shape there. So again, we'll store that. And now we want to turn that into a 1. A couple different ways that we could do that. This wouldn't be too bad if we just divided by 6 or multiplied by the reciprocal of 6, so negative 1/6. These aren't going to be too bad as far as fractions go, so we'll go ahead and do that. You could get some fancy combination of 6 and 7 to turn that into a 1, and then you wouldn't have to work with fractions. I'd probably only do that if I were working on this by hand. So let's do the reciprocal of 6, negative 6, times row 2. So I'm going to make that command from scratch. So we're going to do times a row, and we're going to do alpha y equals. So negative 1 on the top, 6 on the bottom, comma, the name of the matrix, comma, which row, row 2. And we like what that did. We really don't care about those fractions because the calculator is going to take care of them for us. I'm going to store that, and then I'm going to look at the 1 and these guys right here. So I need to add negative 3/2. So this is going to be negative 3/2 times row 2, add to row 1. And I need to add a 7, so this is going to be 7 times row 2, add to row 3. And then we'll go ahead and carry out those commands. So I'm going to go back and find a times row add command. Should be right there. And we're going to go at it like this. I'm going to hit delete and insert that fraction. So alpha y equals, and it's going to be a 3 on the top and a 2 on the bottom. We're multiplying row 2 and we're adding to row 1. Make sure that looks right. Hit enter. It does what we want. That's fabulous. So I'm going to save that. And then I do the next one. We're going to turn that into a 0. So I'll recall that times row command. And we're going to turn this into a 7. So I'll just put a I'll put a 7. Whoops, there we go. I'll put a 7 right here and delete. Oops. Yeah. So, oh, darn it. Deleting those fractions can be kind of tough. So let me recall that again. I'm going to, let me get this, I'm going to delete, nope, delete, delete, oh, that's a mess. Might want to do it by hand. There we go, there we go. So I'll insert this, and that is a 7. And we're going to multiply row 2 by that, and we're going to add it to row 3. So there we go. That was kind of a mess. Okay, but it did what we want, so we're in good shape there. So I'm going to store that, and we're getting there. Now we need to turn this one into a 1, so we're going to multiply by its reciprocal. So that's going to be -3/4 times row 3. And I'll probably just build that one from scratch. And we'll do the fractions. For this one, maybe I'll just put it in just as a -3 divided by 4. If you do that, you have the possibility of introducing fraction or decimals, but we'll just play around with both of them at this point. Oops, forgot to put the row and comma, and that was row 3. So it did what we want, and I better store that. Okay, that looks good. And then the last thing I need to do is I just need to turn that -1/3 into a 0. So we're going to do, let's see, this is going to be 1/3 row 3, and we're going to add to row 2. So I'm going to hit, let's see, what do we got here? We got one of those back here. Hopefully not too far. There we go. Come back here, and I'll hit alpha y equals. We'll do the fraction. So I've got a 1 on the top, a 3 on the bottom. Hopefully this works. I'll hit delete. Yep. And then row 3, and add it to row 2. And that did what we want. Okay. So I'm going to hit store that. And so the matrix that we finish off with is, and this is tough to fit all this on here, I'm writing kind of big and sloppy, 1, 0, 0, -2, 0, 1, 0, 2, 0, 0, 1, -2. So the answer on this one is -2, 2, -2. Okay. All right, let's take a look at the end of this one. We've got a few more. This has been a long practice test. It says find the inverse of each matrix if it exists using a calculator. So these are 3 by 3, so we get to use a calculator on both of these. So I guess I'll have to shrink this down. I'm going to hit clear the home screen off. And the great part about this is when we're doing this, all we have to do is just type it in. So this is a 3 by 3. -6, -4, 0, 0, 1, 4, 5, -5, and 0. Okay, let's check and see. I think we're in good shape. Second quit, I'll display the matrix. Yep, looks good. And then I just have the calculator spit out what the answer is. So we're going to say, hey, I want you to take the matrix A, and I want you to find the inverse of that. And we hit enter, and there it is. It does put it in decimals, and we're going to have it change it to a fraction. So I'm just going to hit math, change to a fraction, and we're going to write these down. So this is -1/10, 0, 2/25, -1/10, 0, -3/25, 1/40, 1/4, whoops, I'm going to make that look right, 1/4, and then 3/100. And then we do the same thing on number 15. We're just going to type this in. So I'm going to hit the matrix menu. We're going to edit the 3 by 3, and we're going to make that a 0, and a 2, and a 0, and a -2, and a -1, and a 2, and a -4, and a -5, and a 2. Okay, and we'll hit second quit, clear this off, display the name of the matrix, double check and make sure that we've got everything in there the right way, and then again it's as easy as just having this do the inverse, and there it is. We'll have it change it to a fraction, so we'll do math and fraction, And there it is. So the answer on this one is -1, 1/2, -1/2, 1/2, 0, 0, -3/4, 1, and -1/2. Okay, really easy. Just type it in the calculator, spits out the answer. And then it says write each system of equations as a matrix equation, and then solve the equation using inverse matrix in a calculator. So I'm going to set these up, and then we'll do these both at the same time on the calculator. So here's what we want to do. We want to write down the coefficient matrix, which on this one is 1, 2, 1, 2, -1, 3, 2, -3, -5. We'd multiply that by the variable matrix, which, because of these variables, x, y, and z, and that would equal the column answer matrix, which is 10, -5, and 27. So this is a 3 by 1, 3 by 3 multiplied by a 3 by 1, and we end up with a 3 by 1. And in class, we actually talked about how this works and why it works the way that it does. So this is going to be x is equal to some column matrix, and we just need to have the calculator do this, because what we're doing is we're doing a times x is equal to b, and then I multiply both sides by the inverse of a. These cancel each other out, and I end up with x equals a inverse times b. So we're just going to put this in as a, this in as b, and then we'll have the calculator do the multiplication for us. So let's set this one up that way. And we've got to be a little bit careful on this one. So notice that on this one we've got a 1, a -1, a 1, and a 2. And then we've got a 1 and no y's, so that's going to be a 0, and then a -1 and a 1. And then we've got no x's on this one, a 1, and then a 2, and then a 0. So we've got to have, thinking augmented right here. Okay, so that's the coefficient matrix, and then x, y, and z here, and that would equal our column matrix of 2, 1, and 0. Okay, so x is going to be equal to whatever our calculator spits out for a inverse times b, and then we're just going to write down the answer. So let's go ahead and throw this in the calculator and see what we end up with. I'm going to hit second quit, clear this off, matrix, and we're going to edit number 1. That's going to be a 3 by 3. So all we have to do is just type this in. So this is going to be a 1, a 2, a 1, and a 2, and a -1, and a 3, and a 2, and a -3, and a -5. Double check that I've got this in here matching, and I think we're in good shape. Okay, I'll hit second quit. I'll go back to the matrix menu, and we're going to change B. Whoops, got to edit that. There we go. It's got to be a 3 by 1, and we're going to put in 10, -5, 27. Double check and make sure I've got that. Okay. All right, looks good. So now on the calculator, I'm going to do this. I'm going to hit the name of the matrix, A. I'm going to have it find the inverse, and then I'm going to have it multiply it by matrix B. Hit enter, and there it is. So the calculator says 7, 4, -5. So that means the answer on this one is 7, 4, 5. Oops, -5. That's the point where these planes cross. So we've got that one. And then all I need to do for the last one is just edit these again. So I'm going to go back to matrix. We're going to edit. It's a 3 by 3, but I've got a 1, a -1, a 1, and a 1, and a 0, and a -1, and a 0, and a 1, and a 2. All looks good. Second quit. Go back to matrix, and we're going to edit. We're now going to edit B and make sure that's right. So I've got a 2, a 1, and a 0. Looks good. So I'm just going to recall that last one, just A inverse times B, have it spit out the answer. It gives me some decimals, so I'll have it change it to fractions. And I end up with this. So 5/4, -1/2, and then 1/4. So the answer on this one is 5/4, comma, -1/2, comma, 1/4. And I will put a box around that. And then I've got my answer. Okay. Long practice test. Takes longer to talk about than it does to actually do. Good luck on the test. Thanks.